Today we're doing 5-3, solving polynomial equations, and your learning goal is for you to be able to solve the equations by factoring. What's going to happen is everything we've been learning so far about factoring and the zero product property, now it's going to come into place. And when you are doing these problems, you want to make sure you always look for the GCF. I'll do this in another color first. Okay. You want to make sure that your equations always set equal to 0. So like in this first example, you notice it's not. So you want to make sure everything is on the same side. Like this. And then you're going to factor out. I'm going to factor out an x. And then once I get here, once you get to a quadratic, you can choose now, because you can choose to try to factor it. You can use quadratic formula. Which will always work. Factoring won't always work. And of course, there are some students that like to complete the square. So those are your options. Alright, so I'm going to try to factor this. Whatever factoring method. I always do grouping, but you can do however you want. So after my grouping, these are my factors, plus my GCF, and then you'll set them all equal to 0. That's called the zero product property. So my solutions will be x equals 0, -1/2, and 3. Let me show this here. So x will be -1/2, and x will be 3. And then you're done. So we'll try another one. Here's another example where it's not equal to 0. And very important, when you bring over the 6x cubed, you want to do that one next so it can be in descending order. And then I'm going to factor out a 3x squared. Here I am to a point where I cannot factor this, because you can't find two numbers that multiply to give you 4 to add to give you -2. Which means you can do quadratic formula or completing the square. I'm going to set my first factor equal to 0. Divide by 3. Square root both sides, so x equals 0. Then over here, I'm going to use quadratic formula. And it doesn't matter. You could use completing the square if you want. I'm going to show you both ways. And don't forget to simplify, because I ended up with a negative. That's 2i radical 3 dividing both, you'll get 1 plus or minus I radical 3. So that's two solutions because it's plus and minus. And x equals 0 had a multiplicity of 2. That makes it 4 solutions. Now, if you wanted to do completing the square, I know some students like that method. Then you would move the 4 over, and you put the number that does belong, which is 1. And then you write that as a perfect square. Excuse me, that's a negative 4, which will make this negative 3. Then you square root both sides. And see, you get the same answer. So you can do completing the square or quadratic formula when you can't factor it, or those two methods, quadratic formula and completing the square, will always work. Okay, here's another example. I'm going to subtract the 4 over first. You always want to make sure your equation equals 0. And then I'm going to factor it, just like I would do if it was a quadratic, except I'm going to have an x squared and an x squared. And I need two numbers that multiply to give you negative 4, but add to give you negative 3. So that would have to be negative 4 and positive 1. And then from here, this can go further. Because it's a perfect square. And then I'll set each of my factors equal to 0. This one, and this one. So here x gives me negative 2. Here x gives me positive 2. Here I'm going to subtract 1, square root it. So x will be plus and minus I, because there's that square root of negative 1. So my degree, which was 4, says that you should have 4 solutions. They are negative 2, 2, positive I, and negative I. This is an example of a polynomial with 4 terms, so we're going to try factor by grouping. So I'm going to group these 2 terms and these 2 terms. I'm going to pull out the GCF, which in the first one be x squared, and you're left with x plus 2. And here my GCF is 5, and I'm left with x plus 2. That way, the terms I pulled out, x squared plus 5, will be one of my factors. And the ones that are in common would be my other factor. And then you just set them equal to 0. So x would be negative 2, subtract 5, remember it's plus or minus I square root of 5. So my degree is 3, so I should have 3 answers. You have positive I root 5, negative I root 5, and negative 2 are my 3 solutions. So your degree will always tell you how many answers there are. And the last, we'll do one more. These are perfect cubes, and we're going to use, you can use sum or difference of cubes. So the first thing you have to do is know your perfect cubes, which are 1, 8, 27, 64, 125, 216, 343, 512, 729, and 1000. Okay, so you need to know these. Then what you do first is how you factor this. First thing you want to do is cube root my two terms. So the cube root of 8x cubed is 2x. The cube root of 27 is 3. So that's your first thing. Then we're going to use what we call SOPs. This is an acronym to help us when you're factoring cubes. So the first S, that means square my first term. So I'm going to put my first term in blue. So that would be 4x squared. O stands for opposite sign. So opposite of minus is plus. P stands for product. That means multiply the blue and the pink. So that'll give us 6x. And the last S means square your second term, which is 3. And that's how you factor it. You will never be able to factor this part. So when you set these equal to 0, this one you'll just solve for x regularly. This quadratic you can only do completing the square or quadratic formula. So I'm going to do quadratic formula. All over 2a. So simplifying it, I'm going to get negative 108, and then I'll just break that down. To 36 and 3, so that'll be 6i radical 3. And from here, remember you separate your real number, but you have to, so negative 3/4 plus or minus or you can write it like this. So either way, but if you want it in that form, just be careful when you write it that it's not under the radical. So you might want to write it so it's like that. So my three answers are, I'll write it at the top. X equals 3/2, negative 3/4, plus 3 square root of 3i, and negative 3/4 minus 3 square root of 3, 8i. Okay, so that's how you do. You got to know your perfect cubes, though, to know when to do sum or difference of cubes. And I think we've covered all of the factoring that you're going to encounter in this section.